Okay, we have two derivative questions on the spot. The first one is that we will differentiate inverse sine of tangent x, and for the second one, we are going to differentiate inverse hyperbolic sine of tangent x. Notice that the inputs are the same, but this right here is the inverse of the original sine, and this is the inverse of the hyperbolic version of the sine. Let's see which one will give us better simplification, and now let's begin with the first one. Well, you have to remember this. Whenever we differentiate inverse sine, we get 1 over square root 1 minus whatever the inside is, and then you have to square that. So this is the usual form, right? On the other hand, if we differentiate inverse sinh, right, this is the hyperbolic version, we get 1 over square root 1 plus, and whatever inside, we have to square that right here. Well, let's see. This right here is tangent inside, of course. And don't forget, we have to use the chain rule. So we are going to multiply by the derivative of this. Derivative of tangent is secant square x. And this is just the original version, right? And now we just have the original trig functions to deal with. On the other hand, this right here, of course, will still enter the tangent x inside right here as well. But don't forget the chain rule, multiply by the derivative tangent, which is, again, secant square x. Now, if you look at this right here, is there any way that we can really simplify 1 minus tangent square? Not so much, okay? So I will just leave it like this. I will just keep it as secant square x over, this is square root, and 1 minus tangent square x, like so. Alright? Unfortunately, we cannot really break this apart in a nice way, so I will just leave it like that. But if you look at this right here, what is 1 plus tangent square x? In fact, that's equal to what? Secant square, isn't it? So this right here, altogether, give us secant square x, and don't forget we still have the square root. And then of course, we'll just cancel this out and assume that everything is nice, positive and all that. So we just have a secant x on the bottom. And then we see that this secant x on the bottom, we have secant square x right here. So of course this and that can be reduced. So all in all, this right here simplifies to just secant to the first power x like this. And we are done. Yes, if you would like, if you have to integrate secant x, you can actually put this down right here for the answer, of course. Don't forget the plus c, inverse sinh of tangent x plus c. That would be a possible answer as well. But anyway, this right here is it.